What if a rocket doesn't have enough fuel to reach Mars? It sounds like a dead end, but SpaceX has found a solution. It may sound impossible, refueling Starship directly in space. Today, we'll explore why this is the key to interplanetary missions. Starship is the largest rocket ever built by humanity. Its height exceeds 120 meters, and its payload capacity surpasses any existing system. But to travel to Mars, it needs more fuel than it can carry in a single launch from Earth. The main challenge is fuel. To launch such a giant into orbit, most of its reserves are already consumed. Yet, a journey to Mars requires far more energy. So how can this problem be solved? SpaceX proposes a revolutionary solution: orbital refueling. Several Starships will launch from Earth, one carrying crew or cargo, others carrying only fuel. In orbit, they will meet and perform refueling in space. It's like aviation. An airplane cannot fly around the world without refueling. The same applies to rockets. Without refueling, Mars remains out of reach. But with this step, humanity finally gains a real chance to reach another planet. Starship is designed as a reusable transport for the entire solar system. Its stainless steel structure can withstand the harsh conditions of space, and its unique Raptor engines run on methane and oxygen, fuel that can be produced on Mars. This makes the project truly universal. To grasp the scale, Starship can deliver up to 150 tons of payload into orbit. That's nearly 3 times more than the legendary Saturn V. Such capacity is enough to launch entire modules of Martian bases in a single flight. But even such a rocket cannot fly directly to Mars with a full payload. After reaching orbit, its tanks are nearly empty. Without refueling, Starship can only circle Earth and return. To go further, it must replenish fuel supplies in space. Imagine this: one Starship launches with crew or cargo. Several others follow, carrying only fuel. In orbit, they rendezvous, dock, and begin transferring liquid methane and oxygen. It's like a cosmic gas station. But space is not a highway. There is no gravity, and liquids behave differently than on Earth. To transfer tons of fuel in weightlessness, engineers must develop unique pumps and cooling systems. It's one of the most difficult challenges in the history of astronautics. For refueling, two giant ships must approach each other at 28,000 kilometers per hour. This requires incredible precision. Autonomous navigation systems and laser sensors will help Starship dock, much like spacecraft do at the ISS. After docking, the hardest part begins: fuel transfer. In weightlessness, methane and oxygen behave like floating droplets. To move thousands of tons, engineers use special membranes, pumps, and cooling systems. Any fuel leak in space could lead to disaster. Methane and oxygen from an extremely explosive mixture. That's why safety systems must work flawlessly. The crew's lives and the mission's success are at stake. SpaceX already has experience with autonomous docking and fuel management. Their Falcon 9 rockets have been landing back on Earth with meter-level precision for years. These technologies became the foundation for future orbital refueling. The first SpaceX experiments with fuel transfer are already planned. In the coming years, the company will test how liquid methane and oxygen can be stored and pumped in space. This will be a key step on the road to Mars. One of the main problems is how to store fuel in space. Liquid methane and oxygen just stay at extremely low temperatures. Even slight heating will cause evaporation and the loss of precious resources. To keep the fuel cold, SpaceX is developing special insulation systems. The tanks will be shielded from solar radiation with reflective panels and active cooling. It's like a giant thermos floating in outer space. On Earth, fuel flows downward thanks to gravity. In space, it behaves like free-floating droplets. To guide it to the pumps, engineers use spacecraft rotation and special membranes inside the tanks. A single trip to Mars requires hundreds of tons of fuel. Imagine the scale. One tanker ship can deliver tens of tons, meaning a whole series of launches is needed for a single mission. At first glance, dozens of launches may seem insanely expensive. But thanks to Starship's reusability, each flight costs far less than traditional rockets. That's why the idea of orbital refueling becomes economically viable. Mars lies, on average, over 200 million kilometers from Earth. The journey takes 6 to 9 months. To reach the planet, a rocket needs an enormous amount of energy. If Starship flies without refueling, it can carry either cargo or fuel, but not both in the required amount. That means no Martian bases are possible. Without refueling, only short missions near Earth are realistic. A trip to Mars requires about 1,000 tons of fuel. Yet, after reaching orbit, only a fraction remains in the tanks. That's why refueling is not just convenient, it's essential. Elon Musk calls Mars the key to humanity's survival. To build bases there, we need hundreds of tons of equipment, water, and supplies. Delivering all this is only possible if Starship can refuel in orbit. The first missions will be experimental, delivering cargo, robots, and equipment for resource extraction. Orbital refueling will make such heavy missions possible. Without it, we would be limited to small probes, just like before. Before humans set foot on Mars, dozens of automated missions will be sent. They will deliver supplies and equipment, so that by the time the first astronauts arrive, everything is already in place. Starship will be the main transport for these launches. One of SpaceX's brilliant ideas is to produce fuel directly on Mars. Carbon dioxide can be extracted from the atmosphere and water from ice. Using the Sabatier process, this can be turned into methane and oxygen. Fuel production on Mars not only enables further travel, but also guarantees the way back. Starship will be able to lift off from the red planet, refueled with local methane and oxygen, and return home. Each successful refueling opens the way to larger and larger expeditions. First, small bases, then entire settlements. The more fuel we can deliver and produce, the further and safer the missions become. This is why in space refueling is not just a technical experiment. It's the key that unlocks the door to Mars. Without it, the flight remains a dream. But with it, humanity gains the chance to become a multi-planetary species. If we want to become a multi-planetary species, not just one of billions on Earth, we need to master space. Mars is our first step, and orbital refueling is exactly the move that will make this goal a reality. Orbital refueling is not only the key to Mars, but also the foundation for future missions to other parts of the solar system. With this technology, we will be able to send expeditions to Jupiter's moons and beyond the solar system. First Mars, then other planets. Colonizing other worlds is not a dream. It's our reality. If we can master space and establish regular flights using technologies like orbital refueling, Mars is not just a planet for exploration. It's the future home for billions of people. The key is to start small, build the first bases, establish self-sustained living. And without orbital refueling, we won't even get close to this. Orbital refueling is not just a technology. It's the key that will open the doors to a new era for humanity. We will travel across the solar system, build new homes on other planets. And all of this starts with one step: the ability to refuel rockets in space. Split-scene cinematic transition. Vintage airplanes refueling in the sky, transforming into Starship refueling in orbit. Smooth morph effect. Ultra-realistic detail. Everything must be realistic, with accurate details. No visual glitches. Static camera. Orbital refueling turns Starship into the first true space transport. We are building not just a rocket, but a staircase leading beyond Earth. Each launch is another step on this staircase. The idea of in-space refueling inspires others too. NASA, Blue Origin, and even European agencies are studying similar concepts. But it is SpaceX that is moving the fastest, turning theory into practice. According to SpaceX plans, the first real refueling tests could take place in the coming years. If they succeed, the mission to Mars may happen sooner than many expect. Perhaps we will witness it in our own lifetimes. We stand at the edge of a new era. Orbital refueling is not just a SpaceX technology. It is humanity's chance to leave its cradle and take the first steps into the infinite cosmos. SpaceX plans the first demonstrations of refueling in upcoming Starship missions. At the early stage, they will test transferring small amounts of fuel. This will help validate the technology before full-scale missions. One of the key trials will be testing cryogenic technologies. Engineers must understand how liquid methane and oxygen behave during long-duration flights. The results of these tests will decide the program's success. NASA is actively supporting this idea. Starship has been selected as the lunar lander for the Artemis program. The experience gained with orbital refueling will be useful not only for Mars, but also for exploring the Moon. Every successful test will bring us closer to the first Martian mission. First lunar flights, then orbital refueling, and only after that will it be Mars' turn. We stand on the threshold of the greatest breakthrough in history. Orbital refueling is the technology that separates us from the past and opens the road to the future. For the first time, humanity has a real tool for traveling to other worlds. We all know that our world is not infinite. We live on one planet in an immense universe. But now, for the first time in history, we have a chance to step beyond Earth. Orbital refueling is the first step toward becoming a part of this boundless cosmos. Technologies that once seemed like science fiction are becoming a reality. Orbital refueling is an example of how scientific ideas transform into real steps, opening new horizons for humanity. And these steps are our path to space. For the first time in history, we can not only look at the sky, but travel to the most distant corners of the solar system. And all of this is made possible by one simple yet incredible technology: orbital refueling. Mars is no longer just a dream. We are witnessing the future, where humanity will build its first settlements on another planet. And this future begins right now, with the first steps we take to reach Mars. We stand on the brink of a new era, an era where space will be accessible to everyone. And new worlds will no longer be a dream, but a reality. And this path begins with one technology that will make interplanetary travel possible: orbital refueling. This is just the beginning. It's time to dream and act, time to create the future. Space is waiting, and we are ready to journey into new worlds.